Alright, in this video I'm going to go through the difference quotient problems that they present in section 1.3. So these are just the very basic difference quotient problems. And the reason why I'm doing the video is because I want your notation to be identical to my notation, because that's how you get these problems correct. So I've started writing out problem 64, and you can see that what I did first was to write the function. So here's our function right here, and then I figured out the answer that I would get if I use the power rule. So that's right here. So there's our answer. That's what I want to get. So now let's set up our limit. So I say that f prime of x equals the limit as h goes to 0 of, so the idea is put your plus h next to every single x term, excuse me. So looking at my original function, so you want to just focus on the original function, not on the derivative. So that means that your eyes are going to be only here, and just ignore the answer piece so that you don't write this incorrectly. So here's my limit as h goes to x. So I've taken each little h and I've put it next to the x. And then I did it for the second term as well, and then plus 1. Then because I have more than one term in my function, I am subtracting this as a box so that I distribute my negative correctly. So that is a good procedure to get in the habit of doing. And then here's your denominator, just what we have normally right there. And don't lose sight of the fact that what this whole thing is just the change in y over the change in x, or slope. Alright, so now what you have to do next is you're going to need to expand this right here. And then you can get rid of these parentheses, and you can get rid of that box if you distribute your negative. So that's what our function has to, that's what has to happen to our expression first. Alright, so I've expanded my x plus h, and I've multiplied it by -2. You want to do this piece right here very carefully. You may even want to do it off to the side to make sure you get it correctly, and then put it in so that you don't have any errors. Because remember, if you expand that incorrectly and you mess up a subtraction sign, or you don't get the 4xh, it's not going to work out in the long run. So do it carefully over to the side if you need to. That's totally fine. Then the next thing is I got rid of these parentheses right here by making this a standalone. Okay? Then I'm going to, don't forget the 1, bring along that 1 because that is easy to forget. And then the next thing we're going to do is distribute the original function. So I've done that now also. So here's my entire line. Everything's expanded. I've not crossed anything out yet. The next slide, I'll start crossing things out. Alright, here is 64 continued, and you can see that in this next step right here, I've just rewritten everything for you so that here I'm going to now start canceling. So here comes the canceling. What you should have happen is that every term that does not have an h next to it will, so all the terms that don't have h attached to them will cancel. If that doesn't happen, go back up. So what do I see canceling? So let's look at that carefully. So this term is going to cancel, and there it is. This is going to cancel, no h with it, there it is. That's going to cancel, there it is. Okay, and then the denominator, you can cancel those because they have partners as well. Alright, so everything's canceled. Then my next step, which is right here, we're now going to factor out the h. Factor out your h and cancel it. I've then rewritten it right here, and when I rewrite it, I have it nice cleaned up. It's still f prime of x equals the limit as h goes to 0, and then my next step, I actually put in the 0. Notice I'm no longer saying I'm taking the limit. This is the limit now. So your final answer is here, and that's exactly what I got when I first took the derivative of my original function. Okay, a couple of quick things. This notation right here is a must. You have to write that every time until you actually take the limit. I am taking the limit right here, and that's why I don't have that limit as h goes to 0 notation written down. So that is 64. You should be able to do it as concisely as I've done it. If you only copy this and don't think it through, it does you no good. So make sure you are thinking it through and then check my work against your work. Because when I ask you to do this on an assessment, which I will, if you've only gotten used to copying, you will not be able to do it. So use my resources wisely. We're going to go on to the next problem on the next slide. Okay, here is question 65. So up top, what I've done is I've taken the derivative so I know where I'm going with this. I am able to take the derivative using the power rule. There's going to be a time when you will not be able to take the derivative using the power rule. So that's why you want to know these steps well so that you can get any derivative, even if it doesn't conform to the power rule, just by taking the limits. All right, so we know where we're going, so let's get there. So your first step is going to be to write out the whole difference quotient, and that's this step right here. So we've written out the difference quotient. I've used my nice boxes so that I'm distributing correctly, and I'm all set to expand the terms. So remember, when you're taking the limit as h goes to 0, you are writing the equation of the slope of the secant line. Once h goes to 0, you then are taking and finding the slope of the tangent line, which is your first derivative, and that is our goal. So as long as we have our h's in there, and our h has not gone to 0, it is the equation of the slope of the secant line. So just keep the big picture in your mind. All right, next step, you're going to expand your functions that are squared. So I've expanded them, I've distributed, I have it all set up. Then I rewrote it for you. You don't have to do the rewrite, but I rewrote it here so that I can cancel and you can see what I'm canceling. So again, every term that has no h with it, you should find its partner with the opposite sign. If you don't, stop and go back and check your algebra. Don't go forward, it's only going to get worse. So there are all my partners. Let me just erase all those little marks for you so you can see. Okay, moving on now. Once I've done that and canceled, then my next step is always to factor out the h. This is by far the safest way to do it. Can you reach up and cancel? Yes. Will you make a mistake? Most likely. So don't do that. Follow my way. It is a nice, concise way, and it'll be successful for you, I believe. Okay, our next thing, it's still taking the limit. I've just rewritten it without having things canceled so you can see. Then my limit notation is limited, shall we say, to here. Once I actually take the limit, which is putting in my 0 for my h, then I don't need to write the limit as h goes to 0 any longer. So here is my final answers. That's with the 0. This next one's without the 0, and if I check my original, this answer matches this, and it's a happy day. Okay, so once again, look at my work, but see if you can do your work first so that you can internalize how to do this. We'll do the next problem on the next slide. Okay, here is problem number 66. Again, my procedure is, since I can use the power rule, I do this step first for myself so that I know that my goal is to get this whole thing equal to x at the end of the problem. So I know where I'm going now. I also know that I have all those 1/2 and I have an x squared, so I have to be careful to make sure I distribute everything correctly. Here is my first problem. I've written it out like this for you. So you can see I've got work to do. I have to FOIL this. I have to distribute in here. So that's what I do in the next step. So here in this step I have everything expanded, and now remember I'm looking to see if I can have my terms that do not have an h multiplied with them to cancel with another term that has the opposite sign. Again, at this point, this is the equation. This is the slope of the secant line, and you're going to get the slope of the tangent line by having h go to 0. Alright, so here is my canceling step, and you can see I'm looking for the opposite of this, and I find it here. The opposite of this I find here, and that's all I really need, and then in my denominator I have those opposites. So now I'm all set to go. So my next step is after I cancel those, I rewrite the problem right here, factoring out my h. I'm cleaning it up in the next step. So here is my nice little cleanup step, and then it's not until I get to the next step, these two steps, I'm actually taking the limit. And once again, I take the limit by putting your 0 in wherever you have an h, and look what's happening. When I get rid of that 0 term, my slopes, my first derivatives, my equation, my tangent line slopes all match. So that's good to know. Look at this work, see if you can follow it, and then I'll do the next problem on the next page. Okay, here is problem number 67, and we have a cubic in here. So remember, you may want to do this off to the side. If you have your x plus h cubed, that's going to equal x cubed plus, remember binomial expansion, 3x squared times h plus 3x h squared plus my h cubed. So that's your expansion, and here's your little workbox, and when I get to that, I've got it. So let's look at the problem that I've made so far. So we can see in the top, you have your problem, and then I figured out what my slope is, so I know where I'm going with this problem. So looking ahead, I see initially this step right here is a nice setup. Everything is nice and neat. And then in the next step I do the expansion, and look, this is what you need in here. And it looks like I may have forgotten my h cubed. So I'm going to write that in, so that's good to know. As I look at it, I see that there is a little mistake in there. So let's see where I'm going to fit that. I'm going to fit it right in here. So right in here, I would have an h cubed. Okay? So that's good to know. Everything else is good. So that means over here, I'm going to have a plus h cubed. And that means that over here, I would have a plus h squared, and then over here I would have my plus h squared still. So then here I would have 0 squared. So sorry for those little mistakes, but see, by doing this off to the side, I've found it. So again, the procedure is expand everything correctly as opposed to the way I did it, and you're looking to cancel your terms that don't have h's with them, then factor out that h in this problem right here. Once I factor out my h, I'm left with my nice limit as h goes to 0. Put in your zeros. Once you put in your zeros, you don't need to say limit as h goes to 0 again, and then you're all set. And what you should find in the last step, if everything is worked out correctly, I am seeing that, let me go backwards, I'm seeing that my answer down here matches what I thought I was going to get using the power rule up there. All right, so make sure you have your h cubed term in it just the way I did it, and then you're going to, here I'm going to put this back in, plus 0 squared. You're going to get ready for question number 68, which will be on the next slide. Okay, here is question 68, and you can see that we can take the power rule to find our derivative, so it's right there. So that's where I'm going with this problem. So let's set it up, and we're going to have a cubic experience again, and this time I have all the cubic done correctly, but I had to sneak in a little -2 when I expanded my x plus h squared. So see what I've done there. Here is your original setup. Alright, we see what we're doing. We're making sure we're having all the terms involved. We're making sure we use our bracket so that we get that entire function with the negative distributed correctly. Then go down and now go ahead. You've got a cubic to expand. You have a quadratic to expand. And you have a -2 in there. So be careful so that you can see I caught my little mistake. That all works out. So here's this step all expanded. Now in the last step, what we're doing is we're canceling our terms. And that brings us down to this step where I can cancel my h's. So now we're going to do the rest of it on the next slide. Alright, here's the end of this problem. And you can see that in this step right here, we've canceled. I've kind of squeezed in that -2. This next step, I'm getting ready to take the limit. Here it is all cleaned up. That's the last time I have to write limit as h goes to 0, because in my next step, I actually take the limit. So here I am taking the limit. My secant line is becoming a tangent line. And here's our final answer, and you see if you check up top, it matches what we had. So make sure that you go back and you check all your steps, make sure you have all your terms, make sure you've done it nice and neatly, and your notation is all good.